Hello, welcome to another video on matrices. Today we're looking at matrix multiplication and looking at how to multiply two matrices together. So in order to do that, you do need to be aware of a few quirks. The first of which is that it does matter what order you multiply matrices together. That is a bit weird because that's not what we're used to having happen with numbers, or what you could also call scalars. For instance, if we do 2 times by 3, it's the same as doing 3 times by 2. Either way, you'll get 6. Whereas if you have a matrix A and a matrix B, doing A times by B is usually not the same as doing B times by A. Either because you'll get a completely different result numerically from doing it, or because sometimes doing it the other way around isn't even possible. In this video, we're mostly going to be just focusing on how do you do the calculation itself when we're doing multiplying, and then my next video I'll be looking at how you're meant to know when you can or can't multiply matrices together. So do watch out for that video. Okay, and then the general idea of the process is we're going to be selecting rows in the first matrix that was written, and then selecting columns in the second matrix that was written. It's always going to be that way around. You can't pick rows from the second and columns from the first. It's always got to be rows from the first matrix, columns from the second matrix. And then, based on which rows and columns you choose, does affect what number you're calculating for your final answer. Because the answer is going to be a matrix, and of course matrices are made up of a whole bunch of numbers. So it's always important at every stage of the calculation you're aware of what number within that answer matrix you're actually trying to calculate. But how does that work? Let me show you an example. For instance, if you pick the first row and the second column in those two respective matrices, that means in the answer you will be looking for the number that's in both the first row and the second column, which would therefore be that number in the top right hand corner. Whereas instead, if I'd chosen the second row, I should say, in the first matrix, and the first column in the second matrix, in the answer, that would be the number that's in both the second row and the first column, which would therefore be, looking at where they overlap, the number in the bottom left-hand corner. You're going to also be trying all the combinations of selecting rows from the first matrix and selecting columns in the second matrix. So that's what leads you to eventually filling in all the numbers you need in the answer matrix, trying all those combinations. But what calculations do you actually have to do with those rows and columns? Let's actually do that calculation now. So for instance, we're going to have to try all the combinations. So first choosing the, let's say for instance, first row in the first matrix and the first column in the second matrix. What I like to visualize it as is me sliding that row down so that it becomes a column and lines up with the other column like this. Once you've done that, that means now all the numbers should be lining up in pairs. And what you've got to do is multiply those pairs together. So we'll multiply the 1 by the 5 to get, of course, 5. And then we'll also multiply 2 by 7 to get 14. In this case, we only had 2 pairs of numbers to multiply together. But if your rows and columns are longer, you're going to have more numbers, more pairings to do multiplying with. All you've got to do is just continue the process on. Multiply all those pairs of numbers together in the same way that we've already done. Once you've done that and got those mini results, what you've got to do is you've then got to add those results together. In this case, I've therefore only got 2 numbers to add together because I only had 2 pairings. But if you had 3 pairings, you'd have 3 numbers to add together, so on and so forth. So 5 plus 14 is 19, and that will therefore go in my top left-hand corner because we did the first row with the first column. Now we've got to try all the other combinations. So now choosing the first row with the second column. Therefore sliding that row down so it becomes a column. We're going to do 1 times by 6 to get 6, 2 times by 8 to get 16, and then adding those results together to get 22. Goes up there because we're talking about first row with second column. On to the next combination when I'll try the second row with the first column. We'll then slide the row across as well again. So the rows always slid in the same way. And then we end up doing 3 times by 5 to get 15, and 4 times by 7 to get 28. Then we add those two numbers together, and you get 43. Just one more combination to try now. We've got to do the second row in the first matrix times by the second column in the second matrix. Sliding the row and then doing the multiplication between the first pairing. 3 times by 6 is 18, and then 4 times by 8 is 32. Cool, adding those together, we get 50, and there you go, we are done. That is our answer, the matrix 19, 22, 43, and 50. But that's if I multiply 1, 2, 3, 4 by 5, 6, 7, 8 in that particular order. If I multiply them together in the opposite order, you do get a different result. But I'll tell you what, you have a go at doing that yourself now. Have a go at multiplying these two matrices together and see what result you get. In 3, 2, 1, pause the video because I'm now going to show you the answer. So the answer is this. So hopefully that's what you got if you tried it yourself. Still the same process, the rows in the first matrix that's been written multiplied by columns in the second matrix that's been written. Okay, hopefully you found today's video useful. As I said, in the next video I'll be showing you how to know when you are or aren't even allowed to multiply matrices together. And so that will be a good video to watch. Goodbye.